Today we're discussing dimensional analysis, and that is simply put a method of converting values of one unit into another. So if I want to go from feet to inches, well, I can do this through dimensional analysis instead of trying to tally up in my head how many inches in a feet and then try to do the math on paper. Here's a systematic approach to doing this. There are two things you'll need to do dimensional analysis. The first one is the original number with units. You'll need the original number with units that you're going to be converting. The second is a conversion factor. And this is what confuses people because they don't know what the conversion factor is. As the definition here says, the conversion factor simply is a fraction that equates two equivalent values that have different units. Another term for a fraction is a ratio, if you're more familiar with that. So it is a ratio or a fraction that equates two equal values that have different units. So if you look down at the example over here, I have a fraction bar in the middle between the 12 inches and the 1 foot. Now that's a ratio or a fraction bar with two equivalent values. 12 inches is the same thing as 1 foot. They mean the exact same thing. And so I put 12 inches on top and 1 foot on bottom. I'm saying the exact same thing there. Another is 1 foot over 12 inches. Those two mean the exact same thing. Even though my numerator and denominator are flipped, it doesn't matter. They are the exact same value. If I divide it by 1, I still get 1. 2 by 2, I still get 1. It doesn't matter. Over here, I have kilometers divided by 1,000 meters. The exact same thing here. For every 1 kilometer, there are 1,000 meters, or 1,000 meters per 1 kilometer. I'm saying the exact same thing. So a conversion factor, again, is a ratio of two equivalent values that have different units. In order to do a conversion, I need a conversion factor. I need to know by what degree am I changing it. Another example is a carton of eggs. We know there are 12 eggs in one carton. I think in America we like the number 12. Or there are 4 quarts in 1 gallon. That's another conversion ratio. They mean the exact same thing when I say that. So now we know the two things we need. Let's do a practice problem. I want to convert 68 inches into feet. So the first thing I need to do, at step 1, we have 5 steps, and the first step is to write down my original number. I need to know exactly what it is I'm converting, and the units is critical to this. I have to have my units, or else I don't know what it is I'm converting, or even if I can convert. So first thing is I write down my original number with units. Here I'm trying to convert 68 inches. Next, I draw a conversion box, and that's just a term I've coined for my classes. A conversion box is just 4 squares that you can box them in later, and you multiply across. This in green. The conversion box can also be written like this. That means I'm multiplying 2 fractions, and this vertical line is just another example of me. That just stands for the multiplication sign, but it cleans it up and it doesn't leave as much space. So we'll draw a conversion box for the first one, so 68 inches is in one box, and another conversion box for the other. So I have my numerator, I have my first numerator, my first denominator, my second numerator, and my second denominator. And first, second. They can be written the same way. You can leave the vertical line out if you want to, as long as you put the multiplication sign in the middle to know what you're doing. After I've created my conversion box, I need to put my original number in the first box, and I have that other box available. In the new box, I put my old unit on bottom and my new unit on top. My old unit is the one I'm going from. So I'm going from inches, and that means it needs to be on the bottom. What's really important here is that it needs to be diagonal. Okay, I can't have it on the same numerator. They're in the same numerator or in the same denominator. It needs to be diagonal. If my unit is in the denominator, then the old unit needs to be in the numerator. If my old unit is in the numerator, then my old unit needs to be in the denominator. So I can cross out at will. Next thing I do, now that I have my old unit on bottom and my new unit on top, I can actually start plugging in values. And this is where I plug in the conversion ratio. As we saw previously, we saw that 12 inches was in 1 foot, or 1 foot was in 12 inches. So we come back down here. And after I put my units where they belong, I need to put 1 beside the larger unit. No matter what we do, we always put 1 beside the larger unit. And then we write down how many times the smaller unit can fit into the larger unit. So for this example, feet and inches. Well, feet is the larger of the two units, so I put 1 for feet. And then I write down how many inches can fit in a feet. Well, we know that's 12. If I was going to do another one for gallons, I would say, well, I have a gallon, and then I have a quarts. Well, the gallon's the bigger one, so I put 1 here, and well, how many quarts? Well, 4 quarts can fit in 1 gallon. That is a correct conversion ratio. That's how you would do that. Next thing we do, after we've got our conversion ratio set up, here we are. This is a conversion ratio. This is 68 inches times 1 feet divided by 12 inches. What I'm really saying is all the way across, 68 times 1, all that divided by 12. So I look down over here, I multiply across and then cross out my units that are diagonal. Then I reduce. So I've crossed out my inches because they were crossed out, and that's what was left. So the only unit that is left is feet. So I have 12 all by its lonesome because there was nothing to multiply across with 12, so 12 is over here by itself, and then 68 times 1 is 68. So I have 68 feet divided by 12. Then I reduce. Well, how to reduce? I just divide both by 12, so 12 divided by 12 is 1. I don't need to write that down. And then 68 divided by 12 is 5.67 with my unit feet. If I don't put my unit, I didn't do anything. So go back up here. How many feet are in 68 inches? 5.67. If you wanted to actually convert that into inches as well, you have to realize that there are 5 feet in 60 inches. 5 feet and 60 inches. You have 8 left over, so that's 5 foot 8 inches. We have another sample problem we're going to try over here. We're going to try another sample problem. Let's say I want to convert 1.92 times 10 to the 4th kilometers, and I want to convert that into a millimeter. Well, here's what I need to know then. As the rule states, the first thing I need to do. First thing I need to do is write down my original number with units. 1.92 times 10 to the 4th km. Well, what's the next thing I need to do? Well, the next thing that I was told to do was to create a conversion box around my old unit, my old number, and my new number, where that's going to be. Next thing I was told to do was to put my old unit diagonally or on the bottom from my original number. So my old unit is kilometers, my new unit is millimeters. Next I'm told to do is to put 1 for the larger unit. Well, what's the larger unit here? A millimeter or a kilometer? A millimeter is 1, and a kilometer, millimeters can fit into a kilometer. Well, now we need to figure out by how much. Well, I know a kilometer has the exponent of 10 to the 3, and a millimeter has 10 to the negative 3. So that is a kilometer, and that is a millimeter. 10 to the negative 3 for a millimeter, 10 to the positive 3. What is that a total difference of? Okay, on a number line, if I were to draw out a number line, if I have 0, 1, 2, and 3, and negative 1, negative 2, negative 3, well, what would that be? That's a total of 1, 2, 3, 4, 5, total of 6. I have 1, 2, 3, 4, 5, 6. That's how many I have. I actually miscounted there. Apologize. And so that's a total difference of 6. So for my new number, that's what I say. There are 10 to the 6. That every time I move over, that's 10 multiplied. Okay? So that's 10 times 10 times 10 times 10 times 10 times 10 times 10. That's 10 to the 6. That's how many millimeters can fit in a kilometer. Now I'll go ahead and undo my math. Let me erase this out so we can have room for this. So I go ahead and do my math. In my math, what I'm making sure to do is multiply 1.9. Let's erase that right there because that was bothersome. 1.92 times 10 to the 4th kilometers, And we're going to go ahead and put a little fraction bars over, if you will, times 10 to the 6 millimeters Well, what happened to my kilometers? Well, down here, over 1 kilometer. Well, what's going to happen to my kilometers? They're going to be canceled out. I don't have that anymore. So I come back down here, and I have 1.92 times 10 to the 4th times 10 to the 6th. And as in previous videos, what do? We multiply exponents. We add them. So 10 to the 4th. What number is really in front of that 10 to the 6th? Well, really there's a 1 there, so I multiply the 1.92 times 1 multiplied by 10 to the 4 plus 6. I finish that down, I come down, I go 1.92 times 10 to the 10th, and what unit? Millimeters. So check my work, that makes sense. Now keep in mind, a kilometer is much larger than a millimeter. Okay, is much larger than a millimeter. So there, I can fit more millimeters into a kilometer. So it stands to reason then my answer should be larger. I should have a larger answer because I'm fitting more millimeters into kilometers. By how much? Well, 1.92 times 10 to the 10 millimeters. I hope that clears some things up.